Hello everyone, I'm Dazhen from Zhejiang University. In this work, we propose a framework for interactive data annotation of racket sports videos. Racket sports, such as tennis, table tennis, and badminton, have similar hierarchical game structures. These sports are popular all over the world, attracting the focus of millions of data analysis and sports fans. For data analysis, optical tracking systems, such as Hawk-Eye, can provide precise trajectory data. However, they are expensive and only deployed in a limited number of top games. For most data analysis and sports fans, a popular choice is broadcast video, which covers different games and supports historical data analysis. More importantly, they are accessible to the public. In recent years, more and more computer vision models have been used to automatically acquire data from videos. However, automatic data acquisition might fail in some cases when there are occlusions or blurring. In addition, the acquisition of some information may require expert knowledge, such as technique and tactic. Therefore, to acquire clean and correct data, we have to introduce human efforts and annotate the data with human-computer interaction. To obtain general requirements on the data, we conducted an expert interview and a survey for general sports fans. For the experts, we collected their analytical tasks and relevant data in their own domains. For the sports fans, we summarized the tasks they're interested in when watching game videos. Based on the interview and the survey, we proposed our interactive annotation methodology, EventAnchor. For the object-level data, we use computer vision models to automatically extract the data from the videos. Based on the object-level data, we derive the event-level data, and further annotate context-level data through interactions. In this work, we implement a prototype of EventAnchor for table tennis to verify the usability of the framework. We extract the object-level data, such as score, scene, ball, and player pose with computer vision models. Then, we obtain events by estimating the moment of score changing, scene changing, the ball hitting, and ball bouncing. For the contextual information, we designed two customized hotboxes for interactive data annotation. Here is our interaction design for anchor calibration. Video will stop at the anchor, and users can control the timeline with a calibration box and revise the spatial position of the anchor by clicking on the screen. We recruited 8 table tennis fans to annotate when and where the ball hit the table. From the results, we discovered that ETT is significantly better than the baseline in task time and temporal error, but has a slightly larger spatial error than the baseline. For context addition, the hotbox supports annotating categorical data. The data can be organized in multiple levels to improve efficiency. We recruited 8 table tennis analysts to find the rallies where it used the tactic of serve and attack and won the rally. The results show that ETT is significantly better than the baseline in task time, but ETT only has slightly higher precision and similar recall compared to the baseline. In conclusion, we proposed EventAnchor, a multiple-level video data annotation framework for racket sports. EventAnchor is scalable, which supports low-level and high-level data annotation for sports fans and data analysis. In addition, it is cheap and accessible compared to optical tracking systems. Thank you for listening.